right, let's go. Headphones out, so that way you can hear me. Okay, so I want to talk about Part D because a lot of the Part C stuff will tie into Part D. I just want to first give you guys an overview of what Part D looks like, and then we're going to do half of it, and then we're going to do the other half later. So, with the Part D, there is a calculation section, and what you're trying to do in that calculation section is verify the acid concentration that the manufacturer has claimed. So there's going to be some calculations here for you guys to do. We're going to hold off on that for now, and we're going to look at the other components. Are we okay with that?
Yes.
All right. On the back side is where you're going to do your summary of your report. And so this is where you're explaining what you are doing and why you've done it. The good news is when you guys do Part D, I give you back everything that you've done so far. I give you back Part A, I give you back Part B, and I give you back Part C. All right? Yay! I have already marked them, so you are not allowed to go and make changes to them. Okay? But you can use it as a reference point. Are you okay with that so far?
Yes.
All right. As you guys see, there are 3 bullet points there, and that means there are 3 different things that I need you guys to write about. And if you guys look at the checklist, depending on what grade you're aiming for, then you know what level of work you need to do for that justification. All right? So, I'll just do a quick overview of that. If you are just aiming for an achieved, I need you to describe some accuracy improving techniques. So the only bullet point I need you to answer if you are aiming for an achieved is, I'm going to start color and coding stuff to make it easy to follow, is the second bullet point. So if you are just aiming for an achieved, you could ignore this one, and you could ignore this one. Okay? Looking again at the requirements for the assessment, for the merit, you need to explain that accuracy improving technique. So achieved person states it, merit person explains why they've done that. Again, if you're aiming for just a merit, you just need to do that second bullet point. You could ignore the first one, you could ignore the last one. Are we good so far?
Yeah.
All right, so hopefully that helps so that way you're not panicking about like all the work that I'm talking about in this lesson, because if you're not aiming for excellence, you don't need to do all of it. All right, excellence is where obviously it is a bit more work. You need to justify your accuracy improving techniques. So you're still doing bullet point number 2, but you're doing it in more depth and detail. You're being more specific on how it impacts the results. You're not being vague and just being like, oh, it's going to affect my results. Why? Is the big thing I would ask for. The other thing that you need to do for excellence is you need to calculate the original concentration of the lactic acid, and you need to compare it against the manufacturer's claim or your lab partner's claim with the purification process. So that is your third bullet point here. This one. So if you're doing excellence, you should be doing both of these two. All right? And don't worry, I'll walk you through what I'm expecting for each answer. The other thing I want you guys to keep in mind is that there's going to be lots of accuracy improving techniques. I only need 2. So you can pick your favorite 2 to write about. If you want to be on the safe side and you're worried you might muck it up, you can do 3. All right? But if you guys remember that list of accuracy improving techniques we talked about, I gave 8. Okay? I don't need you to write all 8. Okay? I just want you guys to know what your choices are. All right. So yeah, that's the other thing you need to do and explain how does it compare against what the manufacturer says. If you guys notice, there's another bullet point here and that first one there. That one you only need to do if you didn't do well in Part A. So you remember how I said don't worry about Part A if you muck it up because you get a second chance? This is your second chance. Okay? Second chance at excellence. So again, the reason why I give you guys all components of the assessment back is so that way you can go to your part A, you can have a read of what you did as your method. So I can have a read and look through what I did here. I can look at part C, I can see what the part C told me to do. Oh, that's part B. And all my little calculations here. And then I can make some comparison. So I can say, this is what I selected for my part A. This is what was given to me in my part C. This is why the part C one's better. Or this is why my part A is still valid. So to keep that in mind. If you've already gotten an excellence on that part A, I don't need you to do that again, because you've already given me enough information to show me that you understand why you did your procedure. If you haven't gotten an excellence in part A, it gives you that second chance to show that you know what you're doing. Yeah.
Oh, so we can just skip the second one?
The first one.
Oh, the first one.
Yeah, you're not skipping the second one, you can skip the first one. So if you're already at excellence and you've already justified, because you've done this bit here and you told me the range and why you have an upper and lower limit, why you selected this dilution, that sort of stuff, then you're fine. Okay? Are we good about that? All right, I don't want to create more work for you guys. So that is really just as a backup for part A. And I'll write that down so you guys know that. Backup for part A. And that's because, like I said, you now know more information. You now know your part C method. You now know your part A method, and you can compare and contrast the two. Are we good so far? All right. I might switch to a different piece of paper to talk about what an achieved merit and excellence level accuracy improving technique looks like, so that way you guys are aware. With this, I've only printed one page for it, so if you do need refill on the assessment or when you're doing your practice, do ask for refill, just use it, because you're probably, if you're going for an excellence, will need more space. All right, so let's just talk about accuracy improving techniques. I'm going to write it over here. Accuracy improving techniques. And what I basically want to do with this is I just want to show you what I'm looking for in comparison between an achieved, a merit, and an excellence level answer, just so you guys know how much you need to write. So the reason why I wanted you guys to write this down when you guys are doing your practical is so that way you remember what did you do to improve your accuracy. And like I said, I've put down 8. You don't need to write all of them. You don't need to memorize them, but you should be mindful when you're doing your experiment what you are doing to improve that accuracy. So this is useful because, like I said, I give you all parts back so you can refer back to this one and copy it down. For the achieved, I want to know what you did. I'm trying to think now off the top of my head what I wanted. And E. For merit, I want you to tell me how you did it, I think, is what I had on my head. And why. Sorry, why you did it is the one I wanted. And then for the excellence, I want you to think about how would it affect your results, and you need to be specific. So that's what I would say to keep in mind when you're trying to think about, okay, what do I need to have when I'm doing my write-up. And like I said, I only need 2. You can obviously do more. All right, so is there anyone on here in particular that you want me to use as an example? I probably won't go through all 8 because it's quite a lot of work But if you want me to explain the reasoning behind why this is an accuracy improving technique, I'm happy to use one that you guys have asked for. So Lena says number 3. Victoria, which one did you want?
You did number 4.
4? Yep, I can do 3 and 4. All right. So I'll do number 3 because this is actually one that you're going to use in a lot of different subjects. So getting to eye level and reading from the bottom of the meniscus. So if I was talking about what I did, I would be describing that as my thing. So I'm going to write down that this is my first example, is that I got to eye level, used a white piece of paper, behind the burette, make sure I spelled burette properly. 1 R. Got to eye level, used the white piece of paper behind the burette, and read the meniscus. Read the bottom of the meniscus. That's a good way to do it. All right, so why did you do that? So when we're thinking about this, I love drawing pictures to show what I mean. So here's my burette, for example. Here's my little measuring things. Let's say that's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's 2. So let's say that's my burette. And let's say my liquid was down here, right? So I got to eye level. Here's my little eyeball. I am looking at it directly on at eye level, and I'm able to then correctly read the value. If I was above or below, we're going to misread that meniscus. So if my eye was above and I was looking down, it's going to affect how I read where the meniscus is, potentially. Same thing if I'm looking at below and I'm trying to look up at something. I could misread the meniscus as being a different level. So why did you do it? To make sure that you're reading the meniscus properly. The volume of base correctly. So that's why we did that. How specifically would it affect my results? So I could overestimate or I could underestimate the reading, and that's going to affect the volume of the titrate that I then write down. If my titrate volume is incorrect for volume, I'm going to then calculate the wrong moles of base, and thus my further calculations for the acid will be incorrect. So that's what I'm looking for the excellence level. And I'll write that down, don't worry. Okay? So how did it affect the results? You would have an incorrect base titrate volume, causing the mole calculation to be incorrect. So do you remember the mole calculation? We know that the moles is equal to the concentration times the volume. So if I get that volume number wrong, this mole number is wrong. And that's going to compound, and I'm going to miscalculate the acid. Affect my further calculations. and I will miscalculate the unknown acid concentration. A lot of your justifications are going to be very similar because it's all about miscalculation. So does that help? Minna, you were the one that requested that, but does that help understand the reasoning? That's why I nag you guys about various things with your accuracy improving techniques. All right, are you guys happy for me to start talking about the next one? Or do you need a moment to process? Moment of process? That's fine. Is there any way you want me to move it so you can try to get all of it in there? Yeah. Do you want me to zoom in on anything? This one is also, I should write down the other thing is what you're calling it is parallax error. Let me just double check the spelling because I'm a terrible speller. We all know this. Yeah, I'll just Google it. There we go. We're trying to avoid parallax error. You probably heard this come up in physics. It's all about how you read rulers. So you're welcome to use that in another subject. Name drop parallelus error. It's a good one to drop. All right, next one? Okay. The next one was requested was checking that there's no bubbles in the pipette. So that's my second one, let's say I talk about. So I checked to make sure there was no air bubbles. In the pipette. Don't worry, I will scan all of this, and it is recording. All right, so if I have an air bubble in my pipette, what does that mean for the volume? Is it over or under what, like, my expected? It's under, because it's basically just a gap of air. So why did I do it? I didn't want to underestimate the volume of acid. Because if I have a bubble there, I'm not getting my full volume. I'm writing it in a lot of detail, just so that way you guys can kind of see what I'm thinking full circle. So I won't get an accurate aliquot volume if there's a bubble in there, because that bubble in there means I'm missing some of that acid.
You're gonna put that on real quick?
Yeah, well, yeah. And I'm recording it so you can watch it again. Yeah. What was I going to say about that bubble thing? So some of you guys, the why, how did it affect your results? So if I have a bubble, I don't have as much acid as I should, so I'm going to be underestimating my concentration of acid. So your titrate value will be lower than what I've calculated. So some of you guys, when I was looking at your stuff, I said, oh, your number's below mine. And it potentially could be because of a pipetting error. So watch out for that. So how it affect the results? The acid concentration would incorrectly be predicted to be lower. Which is not ideal. All right, I'm only gonna write up 2 because I feel like otherwise it's just gonna be a whole lesson of writing, which I don't wanna do. You only need to pick 2 from the list. I would say if you wanna be on the safe side, do 3, because if you make a mistake, then you have a backup. Okay? Yeah. Do you want me to run through the other techniques just to tell you why we do each one? All right, I'll leave that up and I'll just run through the list that you guys have, just so you guys know what the different reasons for. So the first one, rinsing the equipment. 2 main reasons for that. First reason is to remove any contaminants. But the other thing that we have to keep in mind is that we are rinsing things with what we are planning to put inside it. So pipettes get rinsed with acid, burettes get rinsed with base, and the reason why is because I want to clean it, but I don't want to potentially dilute either of those solutions. Because if there's leftover water droplets in my equipment, that's going to dilute my acid or dilute my base. That's number 1. It is recording, so if you guys want to watch this later and write those things down, you can. All right, second one was removing the funnel before reading, and this one I nagged you guys on a lot. Remove that funnel, because if you don't remove that funnel, a drop of base could go down after you read it, and that's going to again cause a misreading of your tide tray volume. And then same kind of downstream effects of how it's going to affect your calculation. We did number 3, we did number 4. Number 5, drying your pipette. So one of the things I try to do is before I try to get to the eye level and check the bottom of the meniscus, I hold it above like the volume. I quickly dry off my pipette and then I release the liquid so that way then I do my measurement of the bottom of the meniscus. If you dry off the excess solution off your pipette, what you're then doing is you're removing any extra acid. So if I had extra acid, I could then be overestimating my volume. So I dry my pipette. Usually it wouldn't be that big of a deal, but if you want something just to do as a safety measure, you can. Number 6 is touch the pipette against the flask. Remember, that helps draw any of the remaining liquid out of the pipette. Again, it makes sure that you're getting that right volume of acid. If you don't do that, then you're potentially underestimating your concentration. Do not take your bulb and the extra out of the pipette, because the pipette is designed to have some left over in it. So that's been factored into the error. So don't do that, because then it's going to cause your numbers to be too high. Someone doing that? Don't do that. All right, number 7 is a white piece of paper to see the pale pink. Again, we want to see that pale pink so that way we have that ratio of acid to base as close as possible so we can do our stoichiometry calculations later. So the white piece of paper helps us get that pale pink color. Same thing for number 8. You do 2 to 3, maybe 4 drops of indicator so that way we can get that pale pink color. If I have a lot of indicator in my flask, it's going to be really sensitive and it'll just turn dark pink automatically and I won't see that pale pink. And that pale pink is really important because that then tells me, do I have my acid and base concentration at the same amount? Cool? So that's covering the second bullet point. I want to give you guys a break from me talking before I do the last part of part D. But you can see part D isn't that bad. All right, what questions do you have? You're good? Okay, so I'm gonna give you guys a little bit of break. Do part C calculations if you haven't done so already. If you have done your yellow part C already, then you can go do the practice questions. Should I give you maybe about 5-10 minute break with doing those calculations and then we can go back and finish D? Okay. All right. Cool. So what I've talked about is enough to get you to achieve, to merit, and halfway to excellence. Let's talk about the other thing I need for the excellence, which is some calculations and this last bullet point here. So in order to answer the last bullet point, we need to do some more math. It's pretty low-key math in comparison to everything that I've given you so far. So what I need to do is go to part C, and I need to grab the concentration that I calculated for my lactic acid. So I look over here, this is my answer, and that answer goes here. So my concentration that I calculated was 0.257 moles per liter. Are we good so far? Moles per liter. All right. Next thing I need to do is identify the dilution factor. So you remember how I said part A, we did a rough titration, and when we did that rough titration, I would end up using buckets and buckets and buckets of base. And so I figured out we need to do a dilution. So I need to go back and figure out what the original solution was before I diluted it, what was its concentration. So we are thinking about, from the information above, what my dilution factor is. So I'm going to go back up here and do some reading. And when we did this experiment, for the lactic acid, we pipetted 25 milliliters of the purified sour cream. And we put it into a 250 ml flask, and then we filled it up with distilled water. So I had my little round bottom flask. I had my little pipette, and I put some of my stock from there into there. And that there was 25, and this was 250. So what full dilution is that if I'm doing 25 into 250? Tenfold. So from this dilution factor, my dilution factor was tenfold. Are you okay with how we did that? That's just a nice little recap from part A. All right. Then what I want to do is figure out my original concentration. So what I need to do is take this number and multiply by what I found as my concentration to figure out the original. So I would do 0.257 times 10, and I would get my original concentration is 2.57 moles per liter. If I did a full dilution like we did the other day, what would you be multiplying it by? If I did a 4-fold dilution, I'd be multiplying it by 4. If you did a 5-fold, multiply by 5. Does that make sense?
Yeah.
So you're multiplying it by your full dilution. All right, because basically we're trying to undo what we did. All right, keep going. Yeah, we're just multiplying it by 10. Yeah. Multiply. All right, keep going. Okay, last step then is I need to convert from moles per liter back to grams per liter. So I've been given the molar mass of my lactic acid, which is this number here. All right. The way we're going to do that is we are going to take our answer here, our concentration, and we're going to multiply it by the big M, and that's going to give us an answer in grams per liter. We don't have to worry about moving any of the units when it comes to the liquid. So I have 2.57 moles per liter. I am multiplying it by the molar mass from over here, which is 90.08 grams per mole. And again, you know I love to write down my units so that way I can double check to make sure I'm doing my math properly. So are the moles going to cancel out?
Yes.
Yeah, mole and per mole. And then do you see how my units is going to be? Grams per mole. Is that what I need to have it in? Yes, convert it to grams per mole. So that's what we're going to do. 2.57 times 90.08. And I get my value to be 231.5 grams per liter. So that's now my final answer. I'm double checking to see if there's anything in here that wants me to do 3 significant figures. And it doesn't say that I need to, so I'm not going to be marking it on that section, I don't think. Are you okay with that so far? So that's how I did my math. So all you have to remember is for both of these parts, you're multiplying. A lot easier than all the other calculations we've done. All right, moving on. Next slide. Okay. So that number there, you are going to be using in this final bullet point, which is comparing the difference between what you've calculated and what the manufacturer or what your lab partner is saying. So my lab partner said that with the purification process, my concentration of the lactic acid should be 11% of the solution. So it should be 110 grams per liter. Did I get that number? No, so something is wrong, and that's fine. That's the whole purpose of this. You're trying to validate if the manufacturer or your lab partner is correct. And most likely, your answer for this is going to be no. And then you can explain why is it a no. So, the claim was 110 grams per liter, and then the actual was, what did I say, 250, no, was it 200? Yeah, 231.5 grams per liter. So this is obviously higher. So, why do you think it could be higher? What could have gone wrong in the manufacturing process? Any ideas? Should I tell you? All right, so there's lots of different reasons that it could be higher or lower. One of the reasons it could be higher is that when the manufacturer makes a product, they might actually make the concentration of the substance higher than what it says on the label. And the reason why is because they're planning for it to get degraded with time, because there's shelf life. So maybe we make it at a really high concentration when we start with, it gets shipped to the storage unit, and then it gets shipped to the supermarket, and during that time process, it will lower to that value. So that's one reason it might be higher. We have a fresh sample, and we're planning for things to degrade. So that's one reason it could be higher. It's a very fresh sample. And hasn't degraded. And so like manufacturer makes it more concentrated, planning in for to plan for degradation of molecule. Of chemical. And that's one example. If it was too low, why could it be too low? Degraded. It's old. It's an old solution, so we need to toss it out. So we could say, so I'll just write it as an if. If number is lower, you'd be writing about how it's an old sample and that the chemical has degraded. There's another thing that you could write about that could fall into both categories, and that's known as quality control. So maybe the quality control was off. So for both of them, we could write that quality control failed. Does that make sense? So whenever you guys buy something, there's something called quality control, and it's not just with food products, it's technology and things like that. And basically they're supposed to test things before they get sold, and that's known as quality control to make sure these items are working as they're supposed to. And sometimes things fail the quality control and then need to be recalled. So you know how cars every so often need to be recalled to replace items? It's because it didn't get caught during the quality control checks. Or maybe you can buy something that's discounted because it failed quality control. You'd be like, well, it works, but it doesn't work consistently. You guys see this sometimes at the supermarkets quite a bit, where they'll be like, ooh, we need to recall this product because actually it turns out it does have trace amount of gluten in it. And for someone that was celiac, that could really cause a bad reaction. And so they recall it. And again, it's because the quality control failed. In fact, there was one with the Chelsea sugar a couple months ago where they found potential lead in, I think it was lead, in their sugar. And so they recalled all of the sugar to be on the safe side because the quality control failed. So it's really important for manufacturers that the quality control works properly. Otherwise, it'd be very expensive to recall everything. And also it damages the reputation of the brand as well. So they want to make sure that these processes work. So, and that's what you guys are doing. You're validating if they have the right claim. And in this case, the claim was wrong. And I'm probably going to give you one with the wrong claim because it gives you more to write about. All right, I know we got 5 minutes left. So what questions do you all have? You okay? All right. What I will do is I will pass out the practice version of part D, which is the yellow paper. So you guys can practice doing a justification write-up. Be mindful how much time we have left in class. I would like to assess part D and part C next week to get this done. So since part D and part C are being assessed next week, be mindful of your time and think about, we have one more lesson in class and then we have the Friday if you want to pop in then. Think about, do you want to spend the next lesson and Friday doing titration? Do you want to spend that time writing up part D and doing that as practice? If you want to focus on doing titrations, because you can only do those in class, do the write-up at home and bring that to me. So you're not losing time in class writing, okay? So I'll pass out that yellow page.